All right, so welcome to this session. We want to find out the exact ideal gas laws. We want to jump into this session and find out how we can work out different kind of questions. So this question is coming from the second assignment that you were given, and we're looking at question 9 and question 10. So the first part of the question is saying, if a gas is collected over water, what corrections need to be made when calculating the volume of that dry gas at STP? So what are we supposed to get for us to find out the volume? Okay, what are we supposed to find out? So I'll underline the most important thing from this question. What corrections or what do we need uh, to find out the volume of the dry gas at STP? Okay, that is what the question is asking us to do. So now the first thing that we're going to do here is we need to note down. So I'll say important note. Okay, I hope my handwriting is visible to you guys. So this is important note. So we're going to answer the first part of the question, which is question 9. So what are we supposed to do here? So for us to find out the volume of the dry gas, okay, which is on water, we are supposed to find out the total volume or the total pressure that is residing on the very same water. So the first part we're supposed to do is what? The gas collected over water will contain the water vapor, which contributes to total pressure. So to find out the partial pressure of the dry gas, we're supposed to subtract the vapor pressure of water from the total pressure. Okay? So the first thing we're supposed to get is the total pressure. Right? So that's the first thing we're supposed to get from there. Then the second thing we're supposed to get from there is the the vapor pressure of water. Okay, we're supposed to get the vapor pressure of water, the vapor pressure of water, because what we're saying here is from the total pressure that is residing at that particular point where the gas is, you're having some vapor pressure of water that is residing at that particular point. So to find out the volume of the dry gas that is present there, we need to first of all find out what is the total pressure of the entire gas. Okay, then we're going to subtract the vapor pressure of water so that we can have the dry gas, because there's the residues of water appearing in that total pressure in that dry gas. So we need to subtract the total pressure from the vapor pressure of what of water. So these are the most important things that we have to get when you are trying to find out, we are trying to get and calculate the volume of the dry gas at STP. And the other thing that I need to emphasize here is that we when they mention STP, which is STP there, they're talking about standard pressure. Okay, when they mention SP, they're talking about standard temperature, right? Standard temperature and pressure. That is exactly what they're talking about there. Okay, and the pressure we're talking about here, when we're talking about STP, which is standard temperature and pressure, we're talking of a pressure of 1 atm, which is standard. It is 1 atm at a temperature of what? The standard temperature here is 273.15 K. 15 K. So that is how you basically understand the STP, which is standard temperature and pressure, at the pressure of 1 atm and at a temperature of 273.15 K. So I want to be very brief as I explain this question, because the first part of the question we have examined that for you to get the volume of the dry gas, you need first of all to find out what is the total pressure residing at that particular point where the dry gas is. So the total pressure is minus the vapor pressure of water, then you're able to get the volume of the dry gas. So basically this is how it works out, because you know that the volume occupied by the water vapor or the volume of the collected gas includes the volume of the water vapor. So to find the volume of the dry gas, you need to subtract the volume of the water vapor. So now in the total pressure there is a certain volume, and then we have a certain volume of the vapor pressure of water. So when you find that difference, the only thing you're going to remain with is the volume of the dry gas. So basically, that is how you work out the first part of the question. So now we can get back to the second part of the question, which is question 10. Question 10 is saying nitrogen is collected over water at 40 degrees Celsius. The first part of the question is saying determine the partial pressure of nitrogen if determine the partial pressure of nitrogen if the total pressure is 99.42 and the vapor pressure of water has been given at 40 degrees at 7.38. I think that's a very easy question because remember from our preamble here we said for us to find out now the partial pressure of nitrogen, we are going to subtract the vapor pressure of water from the total pressure. Okay? So question 10, that is how you work it out. So question 10, you come here. Okay? So question 10. All right. So question 10A. Question 10A. What we're going to do is to find. All right. So to find the partial pressure of nitrogen. Okay. To find the partial pressure of nitrogen. To find the partial pressure of nitrogen. What are we supposed to do? We are supposed to subtract. Okay. So say nitrogen there is equal to what? What partial pressure? Okay. We are going to say we are subtracting the total pressure. The total pressure minus the vapor pressure of water. Of what? Of water there. Okay. So that is what we talked about. So now when you look at the question there, we've already been given the the total pressure. So nitrogen is collected over water at 40 degrees. The partial pressure of nitrogen if the total pressure is 99.42. So the total pressure has been given there as 99.42. Okay? 99.42 kilopascal minus what is the vapor pressure of water. When you check in the question there, you're going to find out that the vapor pressure of water is given as 7.38 kilopascal. And when you find the difference there, the answer you're going to get there is 92.04 kilopascal. And then you're done. So you're done with the first part of the question. So remember, they told us to say we are having nitrogen, which is collected over water at 40 degrees. Then the first part of the question is saying determine the partial pressure of nitrogen if the total pressure is 99.42. So there, what are we supposed to do? To determine the partial pressure of nitrogen, you're just going to find out the basic difference between the total pressure and then you're going to subtract the vapor pressure of water. So that is how you deal with the first part of the question. All right. So now let's move on to the second part. That is question 2, the part 2 there. So what is part 2 asking? They're telling us to say we are supposed to find the mass of water vapor in the gas phase. Okay? They want us to find the mass. They want us to find the mass of water vapor. The mass of water vapor. Okay? In the gas phase. So what is the mass of this water vapor? Okay? In the gas phase. So what is the mass of this water vapor? So how do we go about finding the mass of the water vapor? We're going to get what has been given there. So to calculate the mass of the water vapor in the gas phase, we first need to find the number of moles of the water vapor. Okay, that is how we are going to do it. We're first going to get the number of moles of the. We're going to first of all find the moles of water vapor using the ideal gas law. So now the ideal gas law comes in, and what's the formula for the ideal gas law? That is PV is equal to nRT. Okay, and then while the P is the pressure, the V is the volume, the N is the number of moles, the R is that's the gas constant, and then the T, that is the pressure, that is the temperature. Okay, so we first need to find out the number of moles. So to find out the number of moles of the water vapor using the ideal gas law, so now we're going to assume that we have a volume of 1 liter for simplicity purposes. Okay, so the volume here is 1 liter, right? So when you have a volume of 1 liter, we need to get the number from here. The R is a gas constant, we have it. Then the temperature here, we also have it. It has already been given in the question. So when you get back to our question, let's just go back a bit. You discover that the pressure, the temperature was already given. Okay, so they're saying the mass of water vapor in the gas phase, and this was collected at 40 degrees. And then when you're using the ideal gas law, you're supposed to ensure that your temperature is not in degrees Celsius, but it is in Kelvin. All right. So now how do we do that? So now we come back here. So now to find out the number of moles, we're going to make this the subject of the formula. So this is divided by RT. This will divide by RT, and then we're going to have our number of moles is equal to pressure multiplied by volume divided by RT. The RT here is the pressure multiplied by the volume over the gas constant multiplied by what? The temperature. So now the temperature is at 40 degrees Celsius. And when you're using the ideal gas law, you're not supposed to use the temperature in degrees Celsius. You're supposed to use it in what? In Kelvin. And then the formula for converting now the degrees Celsius to Kelvin is given by Kelvin is equal to degrees Celsius plus 273.15 K. So what is our degree Celsius there? It is 40 degrees Celsius plus 273.15. What temperature are we going to get? We are going to get a temperature of 313.15 K. Okay, that is the temperature that we're getting from there. So now, what is the pressure? The pressure of the gas, the pressure of the water vapor was given in the question, and it was given as 7.38 multiplied by what volume? We're using a volume of 1 liter, right? Then we are going to divide this over the gas constant, and the value of the gas constant we're going to use here is 8.31. Okay, just a minute there. 8.3145 liters multiplied by what temperature? That is 313.15 K. Okay, so now maybe you might be asking, because you've come across different kind of gas constants. There's a gas constant which has a value of 0.08. There's a gas constant which has a value of 0.08206, and there's a gas constant which has a value of 8.3145. So I want you to get me here. When you're using the gas constant of 0.0852, the one we have in here, okay, you have to make sure that your temperature is in atm, right? And then your volume is in liters. Then divided by what mole? The moles, you know the SI unit of the moles, it is just the mole like that. Then multiplied by the K. But when you're having cases where you have your temperature, I mean where you have your pressure given in pascals, multiplied by the volume of liters, divide the moles, then multiplied by the Kelvin, which is the temperature there, then this is the ideal gas we are going to use. So in our situation, we are having the pressure given in pascals. So because the pressure has been given in pascals, the ideal gas law we are going to use here, or the ideal gas constant we are going to use here, is 8.345. Okay, so please make sure that you understand exactly when to use 0.08206 and when to use 8.3145. Just make sure that you have the right SI units. So when you find out the number of moles from here, we're going to have them as 0.028 moles. Then you are done. 0.28 moles. But remember, the question is asking for the mass of the water vapor. So since we have the number of moles, you're going to come here. We have the number of moles. You're just going to say number of moles is given by mass over the molar mass. And we're talking about water here, which is H2O. So you can find out the molar mass of water. That is 1 times 16.01 as the molar mass of water. And then this is 2 times 1.008. And when you find out the total here, you're just going to have your value as 18.015 gram per mole. So that becomes your molar mass of what? The molar mass of water. And then the number of moles you're having here is 0.028 moles, which is equal to what mass of the water vapor over what molar mass? It is 18.015 grams per mole. Right? So now you just cross multiply there to find out the volume. Just come here and cross multiply to find out the mass, sorry. So the mass you're going to get there is what? You're going to get a mass of 0.0504 grams. Then you are done. So this is the mass of the water vapor, okay, which is H2O. Then you are done. Then the other part of the question is asking us to do what? It is asking us to find the mole fraction of nitrogen. Okay, this is another basic simple part of the question, uh, because we are only required to do something just quite easy, because they're asking us to find out what? They're asking us to find the mole ratio or the mole fraction, of nitrogen. So the mole fraction of nitrogen is given by what formula? It is given by partial pressure of nitrogen, okay? Partial pressure of the gas of the nitrogen, divide the partial pressure of the nitrogen, divide the total pressure. Okay? So don't forget this formula. This is how you find the mole fraction of nitrogen. You're just going to say it is the partial pressure of the nitrogen divided by the total pressure, which is just going to give us what? It's going to give us 92.04 kilopascal divide 99.42 kilopascal, right? And then the value we're going to get there is 0.926. So that is how you find the mole fraction of what? Of the nitrogen. So it is as easy as that. And then the other part of the question is asking us to do what? The other part of the question, the last part of the question, is asking us to the other part of the question is asking us to find out the number of molecules, so of the nitrogen. So to find out the number of molecules for the nitrogen, the first thing we're supposed to do is to find the number of moles of the nitrogen using the ideal gas law, which we found already. So when we get back here, we found out the number of moles of nitrogen. Okay? So we get back to our previous page. Okay? When we get back to our previous page, we are going to find out that what we had, okay, here, what we got was these were the moles of the water vapor. Okay, so we need to find out the moles of nitrogen. So now we're just going to use the ideal gas law. So that's part of the question. The ideal gas law is given by PV is equal to nRT. We're going to first of all find out the number of moles before we could find out the molecules. So, and then divide by RT. The number of moles will be given by pressure multiplied by volume over RT. Right? And then the pressure from there that we're going to get is what? The pressure of the nitrogen that was given was equal to 92.04. If you check your question there, it has been given as 92.04 kilopascal multiplied by a volume of 1 liter standard, right? Divide what? The gas constant 8.3145 liters. I mean, the gas constant, the SI units for the gas constant, you know that because I think I'd already explained that, multiplied by 313.15 K. Okay? The number of moles you're going to get from here is 0.0352 moles. Okay? So of the these are the moles of the nitrogen. The other thing that we have to do here is 1 mole of a substance, we know using Avogadro's constant, is 1 mole of a substance is equal to 6.022 times 10 to the power 23 molecules. 23 molecules. Okay? What moles are we going to have here? We're having a moles of 0.0352 moles over y. So what molecules are we going to have here? So when you multiply 6.022 times 10 to the power 23 times 0.0352, we're going to have 2.12 times 10 to the power 22 molecules. So that is 22 there, comrades, molecules. Okay, so that is basically how you work out the equation there. So these are what? These are molecules. Let me just write it well. These are molecules. So you just use the Avogadro's constant. So this is how you basically work out this question. It is that quite easy. So now the first part of the question has been explained as well as the second part of the question. So I hope this is very helpful for you even as you work into those in that quiz. Remember to subscribe to the channel. This is Pomboroka.